Thank you so much, Pascal, and it is my pleasure to acknowledge the traditional custodians of the land on which my institute is based, the Wurundjeri people of the Kulin Nation. I want to pay my respects to elders past, present, and emerging, extend those respects to all Aboriginal and Torres Strait Islander peoples. So I am the host for this illustrious panel on the uses and future of Earth observation. Now, this is a domain previously the preserve of nation states, but today the largest operator of Earth observation satellites is a company. And in fact, a company that was only founded just over a decade ago. So it is an incredibly exciting sector whose growth, whose technological advancements is matched only by the scale of the opportunities of the applications of those data from space. So we're very fortunate indeed to have joining us the panels. And as I say their names, I'll encourage and invite them to take a seat. Of course, we have Aude Vignelles, the Chief Technology Officer of the Australian Space Agency, leading the civil space strategy technical roadmaps, scoping and managing the agency space programs, and delivering on domestic and international activities. I will just note, previous to this, she was the executive manager of the satellite and fixed wireless operations at the NBN and has had lots of years experience in the European Space Agency and sector. Aude, would you please be very welcome on the chair. Round of applause for Aude. We have Olivia Sackett, the Director of Space at Deloitte. She works at the intersections of space technology, AI, climate change, and earth science, delivering business solutions through space that can help the Earth. She also has a PhD from Monash University in hyperspectral imagery of phytoplankton's responses to environmental changes in the world's oceans. And now she gets to do that from space. Olivia. Joining us online, we have Trevor, who is the Asia lead at Microsoft for sustainability science. Prior to joining Microsoft, Trevor led the establishment of the Digital Earth Australia platform at Geoscience Australia, realizing a continental scale analytics platform that enabled Australia to use satellite data, environmental science, and machine learning to improve the management of natural resources. Thank you very much for joining us online, Trevor. And then rounding out online, we have Rémi Andreoli, the Director of Space Applications at BLUECHAM. He has 20 years of experience in analyzing SAR and imagery from space for insights on Earth, including rapid map generation in response to the 2004 Indian Ocean tsunami, as well as working on flood monitoring for the European Space Agency. Would you please make them feel all very welcome? We're going to be COVID safe. We'll just sit in weird gaps. All right, so let's kick off the chat. Olivia, if you don't mind setting the scene about what we mean by Earth observation today.
So Earth observation is really... Are we good? Earth observation really is about studying the Earth system. So we mean like the physical systems, biological and chemical systems. We do that with a variety of different methods. So you can study in situ, boots on the ground, going out and taking samples. You can fly drones and collect imagery that way. And you can, of course, put sensors on satellites and you can detect things from space. And all of these different methods have different benefits. My particular passion is the phytoplankton that live in the ocean and absorb carbon dioxide and turn it into plant matter that the rest of the ecosystems absorb. But basically, we know things about the phytoplankton, like the diversity of the phytoplankton is greater than the diversity of the animal kingdom, because we've taken measurements and looked at them at the very sort of fine level using microscopes. But we also know that the phytoplankton produce about half of the oxygen that we breathe. They play a major role in the Earth's carbon cycles. And we know this because we've looked at them from satellites, looked at the oceans, and we can see them blooming in these huge numbers across the ocean. So each of these different levels of observation gives us different pieces of information about our Earth systems. Okay, now, Trevor, throwing to you online, if someone in the audience today wanted to get into, Earth observation, do they need to go buy a satellite? Is that the first step?
Thanks, Alan. No, look, you probably don't need to go and buy your own satellite. So I'd say there's two parts there, right? First off, there is this incredible wealth of satellite data that's being collected every day today from these, fabulous public missions from the US, from Europe, from Japan, from across Asia, and all of that data is available to be used. It's been kept up to date. There's also then private data sets, satellite providers who are collecting higher resolution imagery that you can purchase and use. So while technology will continue to improve what satellites are there and what data is becoming available, if you really want to get into Earth observation today, if you want to make a change to how the world manages its ecosystems, to how we monitor our water resources, it's not really a matter of going and buying your own satellite. The real challenge and opportunity is how do you take advantage of all of the data that is there, and how do you turn that into insights and into products that really transform how we manage our environment. And it's, you know, it's those sort of activities. And I can't see the audience, but I'm hoping there's 20 or 30 people right now going and starting their own business to do exactly that, Alan. They don't need a satellite. What they need is innovation, and they need data science and new ways of thinking of how to take the data we've got and are getting and turning that into insights.
Where should someone start? You can plug your own prior work here in particular, Trevor, when getting access to that data, because it's one thing to get an image from space, but it's certainly another to have to be able to generate those insights, to ground truth everything else.
Yeah, no, I mean, it's a great point. And it's been one of the big challenges that the world's faced in getting real value out of the billions and billions of dollars that have been spent on satellites, is that the data's been historically really hard to get to, right? So it's been, you know, it's massive petabytes and petabytes of data, typically with like complex data structures and really hard to get to. What you're seeing now are technologies, you know, from the planetary computer, which is, you know, where Microsoft is working to try and bring as many of those data sets to a single location and then make it easy to get to, through to these operational platforms. So Digital Earth Australia, Digital Earth Africa, emerging Digital Earth Pacific, that are taking that technology and then producing these decision-ready products that are made publicly and freely available. And certainly, you know, the Digital Earth Australia platform is this fabulous place to go, both to get access to satellite data that you can then use to innovate, but also to go and get products that tell you about the landscape. You know, how is our land cover changing year on year? How are our water resources changing? There are all of those platforms that are there today and are ready to be used. And I should point out too, one of the real benefits of everything from the planetary computer to Digital Earth Australia, Africa, the Pacific, they're public, like the Digital Earth programs in particular, are public good infrastructure that are open for both private and public use. So they're open for governments to use to make better decisions, but they're also open to the private sector to use to make and sell new products and to drive innovation, because really that's what we're going to need. We're going to need private sector working with the public sector to try and crack some of these really entrenched and really diabolical environmental challenges.
Rémi, one natural, very nice segue to you as a company that is working with these data products from space, trying to gain those insights to Earth. How would you describe from the market's perspective, the experience and the maturity of the Earth observation commercial sector in France, and maybe even, you know, how Australia is trending?
Yeah, in a Earth observation market perspective, I would say that French developers' observation capacity since 40 years now. It was the third country developing Earth observation capacities after USA and Russia, and the second to develop civil capacity with the SPOT program in the early 80s. And France also developed the full space capacity from the rockets, satellite manufacturing, sensors, and Earth observation program. So it's a long history of Earth observation in France, but we are now in a revolution of the Earth observation market. As Trevor said, a lot of data are acquired, and the challenge is to get access to this data and be able to process petabytes of information. We saw the emerging of the Copernicus program from the European Space Agency fully support, of course, by France and the French Space Agency. New satellites are developed, reaching now 30 centimeters resolution, like Pléiade Neo and before Pléiade Neo, American constellations. And in the point of view of the private sector, we are seeing now the emergence of startup focused on making access to answer derived from the Earth observation data and measurement. Like the work we are doing in BLUECHAM and our company in Australia, Quintessence. So in Australia, I would say that the Earth observation market is, our sector is younger than in France, but Australia developed very soon capacities in Earth observation, exploiting satellite imagery from Japan, USA, and also France and Europe. And since the setting up of the Australia Space Agency, and since 10 years now, Australia saw the emerging of new startups like Geoneon or Consilium that also exploit the full capacity of Earth observation to create and provide innovative services.
Thank you very much. So, Aude, I'm keen to hear from your lived experience of the two nations, and in particular, how alike are the space research ecosystems, and what can we learn from their differences? And perhaps Australia is best placed to learn in that instance from the decades, as Rémi mentioned, of legacy that exists in France.
That's a good question. Before I answer, I just want to echo a few comments from all of you. First of all, Australia has been using Earth observation data for 20 years now, from the Landsat, the Sentinel. So we've developed an expertise and a niche of aggregating data and doing something with it. But as being a user, this is where the Earth observation program that we want to do is very important. We want to ensure that we're going to continue having access to this data. So we want to contribute back with some assets in space. And so that's very crucial. We need to be a better partner by contributing something back. EO revolution, don't know who did that, but I so agree that there is a EO revolution around the corner. GPS brought a lot of changes in the way we ride, we command our food. I think it is gonna bring a massive change in what we are doing. Another reflection was during the bushfire we had in 2020. The minister at the time asked us to look into how EO from space can help preventing, managing, and recovering from bushfire. And that to me was an eye-opener. Someone mentioned petabyte of data. Everybody gave us free data, so our server collapsed. We were just not geared up for that. So first lesson is we need to be geared up for better storing of data and aggregating them. But then we realized that we need better revisit time. We need spectral bands that are specific to our fuel load. Our fuel load are eucalyptus leaves. They are not pine trees like in Canada and other countries. So we realize that we have a gap in Australia, and that's where we need the scientist and the researcher to help us, telling us we need data for this, so we can build the correct infrastructure to give all this data. And that brings me to the point in France. We have I remember with CNES and the agency, they're looking at the scientific community and the researcher community to say what is it that we need to do in the next 10 years. And we start doing that in Australia. The decadal plan is a start of that, but it needs to be further detailed, because there was a bit of everything in that plan. We need to be more focused on this is what Australia needs, and this is our contribution. My experience, and I'm not an expert, but my experience of research in both countries, again, in France, is a real life problem. And you have partnership between governments, funding program, and banks. So, France will bring, the government will bring 10% of the funding, the bank, the rest. because they know it's going to solve a real life problems. So that's something that, and again, I'm speaking space, not anything else, not medicine, not because I'm obsessed by space. Space is my only domain of expertise. So that was very powerful. And when you see in Aerospace Valley in Toulouse, all the startups that are exploding, it's because they have a lot of funding from bank. But then the question is also, how do you measure successful research? Is it the number of patents you have? Is it the number of publications it is? Is it because you've been involved in a space mission with NASA or ESA? Yeah. Everybody has his own definition. For our specific KPI in the Australian Space Agencies, we want the research to create jobs. And so again, it's this real life impact, this solving problem that is very, very important. Yeah, let's stop there.
Okay, so we've got this ask now for researchers to try to help drive these missions, tell us what spectral frequency, wavelength a given signal resides at. So Olivia, you've worked with universities on many space projects, including here at Swinburne. How can the unis do more? How can we work better with industry to meet these challenges?
Well, I think there's quite a few things, and Aude, you touched on issues with data and technology. I think we really need to engage in transformational innovation. Incremental innovation isn't going to get us out of the climate emergency. It's not going to solve the biodiversity crisis. And I think that if we think about innovation as like a process, we really need to speed it up, make it much faster, and improve the effectiveness of that. We often do focus on the technology and the data kind of interoperability aspects, and they're of course really important. But I think one of the aspects that doesn't get talked about enough is more like the cultural interoperability. So if we think about cultural interoperability as being about the ability and the motivation for individuals to try to bridge the gaps that exist between different cultures, different groups of people that are trying to work together, I think oftentimes we really underestimate the size of the trust leaps that we're expecting people to take when we ask them to get together and work together. I heard somebody this week say that asking a scientist to share their data was like asking them to share their soul. And I think that, maybe the scientists would resonate with that, whereas other people might, not think about data sharing in that way. But I think if we have more individuals understanding the foundations of collaboration, which is really about sharing, it's about sharing data and resources and ideas. We want people to share them. We're going to have to work on issues related to trust. And luckily for us, there's like a whole science of trust. People like Francis Frey, Rachel Botsman, they've really codified it so that we can understand it and we can teach it and we can practice it and we can optimize it. So when I ask people, how much time have you spent learning about the science of trust? I imagine if I ask people in this room, raise your hand if you've actually spent any time learning about the science of trust. We may see a few hands go up, but probably not many.
Oh, we've got one.
Kudos.
Okay, anyone else? Two. Oh, that's three.
Three. Amazing.
Cool.
So if we think about trust as being the foundation of people's willingness to share with each other, and that's the foundation of collaboration, I think we're going to need to see a few more hands being raised when we ask the question, how much time have you spent actually studying the science of trust?
Maybe I'll just open that up to the panels, Trevor and then Rémi online. And how have your sectors, your experience with those, multi-sector programs, projects, how have you commenced those kinds of projects? How have you built that trust? Trevor, start with you.
Yeah, I'd start with just completely agreeing with everything Olivia just said there, to be honest, as I almost always do. But the point I would make is that it's not just trust between, say, the science and industry or science and government. It's actually within different disciplines of the science as well. But real success in this sort of area, we all recognize that these issues are, they're systems-based problems. They're going to take systems-based thinking, and they're going to require us to be able to integrate people with a deep understanding of Earth observation, with skills from data science, with skills in doing, machine learning that can actually look at a problem differently. And I think, but back to Olivia's point about trust, until we can build those habits of collaboration, which are founded on trust, we won't get very far. And I'd say the counter to actually answer your question, Alan, of where we've had success is where you've brought multiple groups together at the very start to articulate the problem, to be honest about what they can and can't do, and to be fairly clear about the objective that they're trying to solve. So, you know, a really small example from my past was a fairly contentious area of looking at how do we provide an understanding of water availability in the landscape. So mapping across Australia, where is there water? And that was trust between the EO scientists at Geoscience Australia, the regulators and the people who had responsibility for prosecuting, in some cases, water theft, and irrigators. Now, those are three groups that, you know, we've all seen some of the contention around water issues in Australia, but we were able to move that forward by being pretty open at the outset about what we were trying to achieve together, and how we were going to go about doing it. And I think, you know, not being one of the people who raised my hand about having done much on the science of trust, on my own reflection, some of the transparency and honesty at the very beginning is going to be what's important for laying some of the foundations. But yeah, long way of saying completely agree with everything Olivia just said then.
Just turning to you, Rémi, your experience, you've obviously worked in particularly high sense of time pressure environments, generating those rapid response maps, for example. How do you encourage trust, or how do you have trust maybe already in hand for those kinds of occasions?
Yeah, in the beginning of my career, I worked in rapid mapping, the French rapid mapping services. We were producing impact maps within 4, 6, and 12 hours, and delivered to the first responders. And the trust in that kind of information is very sensitive. So we had been trained by the French rescue team to produce the right map, and we were working in close relationship with scientists in order to develop methods that rely on scientific basis that create the foundation to provide products that are trust on the field. There is also a particularity in rapid mapping response because we need to provide information that are specifically dedicated to the end user. And in evolving in my career, now I'm working in a private company. I'm basically working in multi-sector programs every day because my end user at the end are not remote sensing specialists. And I'm working with a wide range of end users, from managers, small tribes in New Caledonia, for example, urbanists, and they all have their own skills and education. But first, we need to educate them and provide them the foundation to understand what is remote sensing and how we can provide services and answer to their question. We need also to develop systems that integrate their own workflow, and basically we are building the trust with them in providing an answer that are useful for them.
And I'll just then have Aude perhaps reflect on the role of government or national organizations in building the space for that trust to occur, perhaps, or encouraging the right incentives for that kind of multi-sector collaborations.
We do several things, but the first thing we do is these roadmaps. When we develop roadmaps, the thing I didn't say is we create tags, technical advisory group, and I think Swinburne sits in each of them. So you guys are the experts in these domains, and we develop the roadmaps together, and we consult with all the other space agencies with whom we had an MOU to see where we can collaborate. And France has been very helpful in each of the roadmaps. Once the roadmaps are done, we implement programs wherever we can. So I'll give an example on the EO program. There is a stream host venture where we need to develop hyperspectral sensors for our own needs. And we are starting to engage with the research community to help developing this hyperspectral sensor. So that's an example. And maybe we're going to collaborate with our other agencies to develop this. But so far, there is a lot of good discussion we're having there. I mentioned on SSA space weather. That's also something we are looking for some research collaboration on that. RNA, so remote operation robotics, the surveying of the resources that we're going to need on the moon to create things, to be able to build habitat, etc. And that's also a research sector we see. I mentioned radiation for space medicine, life science. Comms as well. I mean, you have been involved in all this quantum encryption, lots of research there. And I know that also University of WA is doing a lot of work with ONERA, the French research center. So again, developing programs to encourage that. Access to space as well. Green fuel is a big domain of research. So you can see in all the roadmap, there are some areas of research. And I finished with PNT, so we'll do the 7th one. And everything that allow the accuracy of sensors. So quantum is a big thing for quantum sensing, for the accuracy of PNT sensor is a big one. So we are trying to have national programs to develop this research with the scientific community, but also with International Space Agency. And so we are seeking funding to do that, or we are collaborating with SmartSat CRC or ARC for these matters, because we have a dream to have in ARC some clear space line of funding for all these areas I've just mentioned. So defining the need and then implementing the program and have the right funding and collaboration and tools to implement them.
Okay, I wish you luck in a very self-interested fashion with those funding lines. Trevor, I'll just throw to you and circling back a bit to some of the opportunities or targets for Earth observation that Aude and Olivia have mentioned. There's bushfire, there's water quality measurement. With so much promise, what are the issues that are slowing us down? Maybe not preventing, but slowing us down in that wider adoption of satellite imagery and other data products to solve those pressing needs?
Yeah, I mean, so there's three. One of them, and to be honest, one of them is something that the planetary computer is trying to address directly, right? Which is to do some of the hard, boring work that underpins all of those outcomes, which is organize all of the data, make it all accessible, and more than anything, and this gets to the second point, make it easy to integrate different data sets and different skill sets. So when you think about, if you go back, and again, back to something Olivia said at the start, when we talk Earth observation, we naturally think about satellites, but we're also talking drones. We're also talking IoT sensors. We're talking about a whole range of very, very different data sets if we really want to try to solve a problem as complex as, say, what AquaWatch is going to do, looking at water quality across the country. To do that, you need platforms and skill sets that allow you to integrate all of these data sets and bring new analytic approaches. So we've got to accelerate our ability to integrate those different disciplines and those different approaches. And a really simple example, if you want to be able to use satellite data globally, and again, I'm talking AquaWatch, right across Australia to look at water quality in every inland water body, you need a whole bunch of ground truth data that's been collected and it's been made available. You need the ability to have constant in situ monitoring, and you need the ability to have data assimilation that brings all of that data together and gives you a meaningful answer about what the water quality is. And there's a whole bunch of technology challenges and science challenges that need to be overcome to address that. And they need to be done faster and faster. And that's for every single problem we address. And the third bit, I think, what I would add, this kind of touches on the trust piece, but there's a whole skill layer around translators that are able to actually translate between some of the products and outcomes that you get from Earth observation into meaningful action. Like there's a skill set there that I think we underestimate how important it is sometimes. People who can bridge both between decision makers and their actual practical needs, and what the science and technology actually can do. I think that is a really important skill set. And everyone talks about user-centric design. Everybody talks about thinking of their users and being obsessed with customers. But there's a real skill there that's got to be focused in everything that we're doing to really understand, the systems-based thinking that's needed to solve an ecosystem problem. And how do we actually translate from what Earth observation can do to those problems? So I think that investment in skills is something else that needs to be accelerated.
Look, I'm going to turn to you, Olivia, as someone who's a fluent translator in these different sectors. From the research, you've worked with us in deep AI, but you go to the customer, you speak. Just maybe expand a little bit on Trevor's thoughts there. How does that conversation go in practice?
I'm smiling because most of the things that you said, Trevor, very much resonate. I guess one example is that I spend a lot of time speaking with data scientists about the machine learning models that they're building. And kind of joke that 90% of the conversation is complaining about trying to get data and wrangle data. And, there's a little bit of work that happens on the side. So all that, boring work that you referred to is incredibly valuable because then we can, prioritize that time into other activities. But oftentimes when I speak with what we call an end user, an actual person we're hoping that we might be able to help, we don't really think about the practical steps that they're about to take with this very fancy magical system that we've built. And oftentimes what they do is, especially if it's some sort of visualization system, is I ask the team, well, what do you think this person's going to do when we give them access to this web map? And they kind of scratch their heads. And then I say, well, what do you do when somebody gives you access to a web map? And they say, oh, I type in my address and I look for my house and I zoom in and I say, and what happens if it looks pixelated? They go, oh, I assume it's a bit rubbish and I don't use it. And so even in those applications where actually it doesn't really matter whether you can see it with your eyeballs or not, because the machine learning models can extract the information and we know that. But most of the time, our customers, they don't really have that intuition. It's a very abstract concept. So I think we need to kind of tick a bunch of these boxes back to this, trust equation. That's a trust leap. If you want someone to take an action or to change their path of action based on information you've given them, like you've told them that the fire is here, not there, and they've got to choose whether to evacuate this town or not. Like those are really big decisions. And if you stumble on any of the sort of small building blocks at the beginning, they're unlikely to continue to work with you and to continue to use your product. And they'll think, well, if they failed on these small things, then how do I trust this bigger thing? So I think that we really need to think about these sort of, I guess behavioral science teaches us that future success, the strongest predictors of future success are early and frequent success. And success can be, I looked for my house and I zoomed in and I saw it, tick, success. Like we've got to work out what are these little tests that our customers are going to intuitively sort of test us on. And we have to hold ourselves up to passing those tests, not the big picture tests that, we obviously have to pass the big picture test too, but we won't even get there unless we work out what's going on in the customer's mind, what's their workflow, and what are the hurdles that we have to jump over if we're going to try to make some big impact at the end of the process.
Rémi, maybe if you wouldn't mind following up on that point, when you work with international clients, are they all looking for the same kinds of product services? Are they going through these small tests? Are you navigating that journey with them, or do you just give them a black box and say, trust me?
That's a really good question we are facing quite every day. We are usually for first approach providing some demonstration and pilots. We already have products as a platform where the user can access services and answers from remote sensing. If the customer is new, you want to be confident in the service that we are providing to him, and he will first want to test. On the other case, we also create a network of users, and they can rely on the experience that other user had with some services. And what we saw also, I heard carefully what the panelists said just before. I saw that user, yes, were interested in very high resolution data, but with some users now, and with the revolution we are seeing, actually, I have some end user from the industry, like in mining sectors, who are using a wide range of Earth observation data, from medium resolution to very high resolution, and they are using it according to the answer they want, and they are starting now to handle the complexity of the of remote sensing, because each component can provide them information that they can translate at the end into action. But at the end, the trust is something very important that we have to build at the beginning, either using pilot project or make the end user talking to each other if they have some. If some other user have some success, to share their success with the whole community.
You know, I might turn to you, Aude, about the KPI. The agency has been set around job growth, and a lot of the jobs sit in the small, medium enterprise sector. How maybe as a loaded question, but is it the agency's role to help SMEs get those kinds of international contracts, for example, with France, or to encourage that kind of international collaboration? It's a very steep hurdle if you've only got a few people in your team to entertain external markets. So I guess really, what is the role, if any, of the agency in trying to provide that kind of assistance for collaboration with France, for example?
It's not a loaded question.
Well, it was the way I was going to phrase it initially, yeah.
I was talking with Pascal at the beginning. Finding our niche is the big thing. So first of all, number of jobs. I don't think we're going to create the number of jobs by manufacturing satellites. The big number are going to come from the data that's going to come from these satellites, without a doubt. I think all the conversation there, all the data that we have. So finding the niche of Australia compared to the world is obliged us to have all this conversation as well, because there is a lot of activities in space across the globe, and we have to make sure that if we decide to develop a capability in Australia, it's because either we need to have a sovereign capability in that field, or we are filling a niche. Otherwise, we are highly competitive for whatever reason. But it's a hard world out there. Not only space is super hard, but there is a lot of space activities all across the globe. So our job is really difficult. So we are already engaging with a lot, and this is why the roadmap are taking so long, because we consult a lot on that. But once we found our niche, and I think with this EO program that we have designed, which is really about calibrating data from different satellites. How do I know that the red from Landsat is the same than the red of Sentinel? As soon as I have exactly the same reds, I can do much more things with the data. To your point as well, is a fire there or there? We need to trust the data and calibrating this. So we found that niche because in all our conversation with NASA and ESA, we realized, oh, nobody's doing that. And guess what? To do these satellites, we don't need to do a big 5-ton satellite. We can start with a 50 kilogram and then 100 kilogram. And so it was like the penny dropped. It was, this is our chance. This is our opportunity to shine and to develop this hyperspectral instrument and to start building this satellite. So it's not that hard. And you know, with big conference that we have, ISC, Colorado Spring, and bilateral that we have with all agencies, and France was the first MOU we signed with Vignelles a couple of days after the agency was created. So we're having this conversation regularly, and it's about finding what do I bring on the table and what do you bring on the table. And when we talk with France, and I think most of you know that we had a big French delegation coming in Australia a month ago now, and they went everywhere. And this kind of visits help us as well to see where we can collaborate, because there was 15 companies coming and they say, oh, interesting to do that because we met all these people, and I think that's what the collaboration here. So meeting, discussing this time of forum is very helpful to know what is the niche of each other and how we can build something bigger, because as everybody says, space is something that we do together. We don't do space alone. So it's not that hard, and even a small team. And I think to your point about being a small team, again, we're not going to build anything in-house. We are defining programs. We need strong expertise because you need to be able to say to the government, you know, we can do a rover for 50 million. So we need space system engineer in the team to be able to know if it's possible to build a rover that's going to support, survive the lunar nights. But once we have designed the program, it's down to the industry and the researcher to collaborate and deliver the program. So you don't need that big a team. I don't think we will ever be a 5,000 people agency. I think we're going to remain small, agile, and collaborate nationally, internationally with industry and with science. I think it's we came late in the party, but we don't have all this history and all this big infrastructure and procedures to deal with. We can be very agile and very quick. And you know, 4 years later, when we see all the small grant impacts that I was referring to earlier, it's very good results, and return on investment of taxpayer money we've used for program is very promising.
But legacy is a dual-edged sword for sure. Now, I'm just conscious, how long have we got left, Paul? 10 minutes. Okay. Oh, good. Okay, phew. Okay, I have some more questions. I want to open up the floor to everyone else, and I was thinking I wouldn't get to ask these questions. Rémi, could you give to any Australian industry in the room or online tips to selling internationally, to working, say, in France? I don't want you to be, you know, cutting your own lunch here, but having them cut your own lunch, but just trying to, you know, what are those kinds of bits of advice around working internationally in the Earth observation domain, which is inherently a global domain, but not necessarily a global marketplace at this stage, at least?
Yes, as said before, Earth observation is a globalized market, but also globalized capacities and knowledge. So there is two components. We do not have to reinvent the wheel. So we need to cooperate internationally on the back. I mean, exploiting the full capacity that the space nations can provide, like France, Europe, Germany, Australia, Japan, US, to access data, access services, connect services, and then provide them and share them to other nations. It's not, how to say, some expertise are well developed in some countries, and some countries focused on specificities like mining, like subsidence, like radar, Earth observation, other on optical, and we need to collaborate internationally. So at the end, on the downstream part, services can be provided from another country to another one. That's already the case. For example, we are monitoring mining sites across several countries in the world. Or bathymetry are monitored from in Australia, as an example, and part of Australia are monitored from a company based in Europe. So that's there's possibilities to provide services and capacities from other nation to other nation. There is also some cooperation in the defense sector, of course, to provide support from nations that are doing Earth observation and geointelligence to other countries that do not have the capacities. It needs some agreements and working in a good partnership between nations, between private and public sectors, that all the nation can develop their own expertise, their own skill, and provide additional capacities to the global market.
Now, I'm going to ask a workforce question to you, Olivia and Trevor. You're both in very large organizations. You're employing large numbers of people in the space sector. What is it that you look for, say, to a university to provide you as a graduate in terms of their skills and experience? So, Olivia, you seem very confident, so I'll just throw to you for that question, and then to Trevor.
Well, clearly there's a need for people who have skills in machine learning and data processing, and we've hired quite a few of those. But I think also back to Trevor's point about translators, I've been trying for quite some years to convince people in the data and analytics practice to bring on board people who have really strong communication skills. So maybe like science communication skills and the ability to connect with people and to understand people and to bridge that gap between, you know, the data scientists and the customers. So I think that in a domain like Earth observation, one of the other things I think we underestimate is the depth and breadth of the technical knowledge and skill required. So we need engineers, we need scientists, and we need those translators, because there is such a big gap between, you know, collecting the data and then actually making it useful and helping an individual person. I think probably one of the biggest gaps we've got is in, yes, the people who can actually analyze the data, but also the people who have an aptitude and an interest to build their technical knowledge so that they can help a customer work out what's technically feasible and what might be a good use of the time of the analysts, rather than expecting that the analysts themselves are going to all of a sudden be able to sort of decode what the human being wants and respond appropriately. Trevor, similar?
Yeah, but I would have a slightly different take on it, Alan. So I think I probably would lift up the conversation a little bit around outside of just Earth observation and more, what are the skills we think the world is going to need to actually transform itself to be sustainable, right? So because if you think about it, like over 3,900 companies have already made climate pledges globally, right? There's this growing recognition across governments, across companies, across the private sector, and across, frankly, our entire community, that everyone needs to transform to a sustainable world. And I think Earth observation has got a critical role to play in that. But I think we've got to recognize what we're actually talking about is lifting competencies, these ideas of sustainability competencies across the board, sustainability fluency across everyone in every job, in the same way we now expect digital fluency in every role across the world. And I think when you go back to your question, Alan, of what kind of skills do we think that means? I mean, we're talking competencies like systems thinking, circularity thinking, actually being able to do, you know, design thinking approaches, and this ability to recognize that the future is changeable and we need to envisage and drive towards a different future. And so I actually think the question's bigger than just what skills does the Earth observation community need and universities. I actually think there is a pretty big gap in the sort of sustainability skills that the world needs, and that companies like Microsoft and every one of those 3,900 plus companies that have made commitments need in order to transform every business in the world to be a sustainable business. And I think within the Earth observation lens of that, it's important to recognize companies are demanding these skills, but that same 3,900+ companies are all going to be demanding new insights and new information and data products from Earth observation companies and from everyone else. But I actually think, I suspect the biggest impact will come from those companies that are able to really bridge Earth observation with that full gamut of kind of sustainability products and services that companies are going to need. So I think it's a really big challenge, and sustainability skills writ large is a huge challenge, and it's one that's really important. Microsoft thinks it's a really important space that needs work globally.
Well, certainly as a university with two of our three focus areas, Innovative Planet and Space Aerospace, this music choirs, as well as this very strong focus on design, as well as ensuring our graduates have those workplace placements to actually experience and what industry is looking for. on a question with no notice, I want all of you to just very quickly give me your vision or optimistic vision of 10 years hence, 20 years hence, you pick your time frame, that Earth observations promise has arrived. What does that future utopian use of Earth observation look like? If it's a new generation of satellites, if it's just some artificial general intelligence or general artificial intelligence that's able to make sense of what we already have. What is the future for Earth observation look like 10, 20 years hence? And I know Aude is always thinking big in this regard, so I'll just throw to you with that impossible question.
I like this kind of question that I often ask: if you were queen or king for the day, what would you do to solve your problem? For me, as I said, EU big revolution. I think we want, again, a space satellite EU from space that teach you about things that you didn't think about. Sometimes, so first of all, echoing what Trevor was saying, because we don't say it enough. We talk about net zero, climate change, big problem to solve. Without EU from space, one, we wouldn't realize how bad the situation is, and two, we wouldn't have the tool to monitor which direction we're going. So anytime someone talks about climate change and net zero, we have to make clear that we can fight that with EU from space to make sure that we are addressing these problems, and we're realizing how bad it is or how good it is. So to me, the big revolution is having access on your phone to any data from space that you can have access to solve, again, problem that you need to solve. But also you come to work in the morning with machine learning and even satellite being able to see a problem, or this is not the spectral band that I need, so I take a picture in another band, and doing all this autonomously, also avoiding collision autonomously. So you come to your office and you already have a situation on your screen that you didn't have to look for. And that's also, there was an example, I don't remember which country had this big explosion of a warehouse. So someone was monitoring the feed of the news. So they knew there was an accident happening there, and they tasked the satellite automatically to take picture of that area. Apparently there was a feed news. So they already have all the data they needed when they arrive at work, because all that was done by connectivities of your feed of news, communication feeds, Earth observation data. So connecting all this data, information we have from any source and any types to give you information that you need to make the world a better place. I think that's a big revolution.
Right, that is a very exciting future vision. It's time for your questions. Oh wow, already hands up. So Paul, if we can get one going towards the middle left. Anyone else with hands up? We'll get you lined up. If you just say your name and affiliation, and then ask your question, please.
I'm Jean-Marc Maurice from Business France. I just have a question. To use a metaphor, we in the agriculture field, we said from the farm to the fork. So in the space area, from the space to the ground, I would like to ask this following question about if there is concrete things done in the bushfire area. Any actions have been taken, maybe in Australia? This is such a big thing. Maybe with the different states, the fire departments in different states. Are there actions taken just to have a vision of concrete actions, maybe with Earth observation that have been taken in Australia? Thank you.
I can take that. So that we did actually, we published a report, the bushfire report, and that is available on our website. There was 9 recommendations in there, and 8 of them have been implemented, and the 9th one is about to be done. Examples. Look at fuel loads, because often fires are triggers because there is a pile of leaves here and there. So regularly, all the data of before the bushfire seasons, that is in July and in summer, we're looking at where there is a danger of fuel load, and we send people to clear them. So that's number one. We also look into where is the water. So do we have enough water in strategic points to extinguish the fire when the fire starts? The Bureau of Meteorology also recommended some additional instrument on the Himawari next generation satellite so that we can see how the wind and the lightning and different information that they need to try to understand when we have a propitious bushfire conditions. And also the SAR data. So, you know, CSR was 10% of the NOVA SAR satellites. SAR is very good to see the burn scar. So once a fire has happened, you know where to send reliefs and plant again because it's been burned. So there's been quite a lot of action being taken before, during, and after. Now, some of them are going to take a bit more time because you need to launch a new instruments or a new satellite to get the data you need. But I invite you to read this report because it was really concrete on measure and action that we can take. And it's very informative as well. I learned a lot doing that. And it was done with all the states and territory, emergency services, bushfire from every state and territory because they function differently. And it's a thick report, so no excuse not to read it. But and any feedback welcome because there is still more to do.
Olivia, I might just ask you to follow up. There was a project you led around bushfire, which is a highly motivating topic, and your success in getting students from around the world to work on that.
Yeah, so we ran a global data challenge looking at using remote sensing data and data collected from aircraft as well. To detect bushfires and to also use the maps of fires to then work out where the fires are likely to spread in the next sort of 4, 6, 8 hours. This became important after the Black Summer bushfires because after speaking with the bushfire officers working in the response centres, basically they used to spend sort of 5 to 10 minutes drawing a fire map where they'd bring up a photograph of a fire and then they'd take their cursor and ArcGIS or whatever and they'd draw around the fire. Because the fires were getting so big so quickly and because there were so many of them, it was taking upwards of an hour and a half for them to draw these maps. So basically that's cutting into decision-making time. Instead of wrestling with questions about, you know, all these different trade-offs that need to be made with regard to, you know, we have 2 aircraft that we can send out to drop water. Where should we send them? There's, you know, 20 fires or whatever it may be. Instead of doing that, they were waiting for information to come in. So being able to launch a challenge like that was very exciting because first of all, you know, we had about 10,000 people join up from 118 countries, and a lot of them had never written a line of code. A lot of them didn't know anything about these domains of remote sensing or bushfire. So that was a sort of massive educational campaign. But also we worked for about 9 months with the Bushfire Authority in Victoria to really understand their detailed workflow and to work out what were those hurdles that we would need the students who took part. About 36% were postgraduate and the rest were undergraduate. What were the hurdles their solutions would have to pass for this customer to actually be keen to give it a try, to actually use this potential solution. So we learned a lot about the workflows and about the things that go wrong and what actually happens in the midst of a crisis and what's really informing decision making. And I think that also by trying to codify that workflow, that was very valuable for the bushfire authorities as well, because of course a lot of this happens intuitively and based on people's knowledge and it's in their minds. And until you codify it, you kind of are missing some opportunities for optimization. So I think in some ways, yes, it was great for us because we were able to extract information and to be able to use that to design potential solutions. But I think also for the authority itself, it was great to be able to codify it in a bit more detail, the processes that they were using to make decisions and to potentially find ways to optimize those in the future.
Thanks to Trevor and Microsoft for making possible those kinds of intuitive tools where students who don't even code can still make machine learning products. We've got a question online.
So we have a question from Professor Christine Thong at Swinburne. She says, thank you for this interesting discussion. I enjoyed the trust and translator elements in particular. My question is, how do you get clients or stakeholders on board to invest in transformative innovation, which may be a higher risk? Given that typically with transformative or radical innovation, while the goal can be well defined, what the outcome is or looks like is unknown at the outset of a project.
Well, one way they can is to give give Christine and her team lots of money to do that design thinking work. Does anyone want to tackle that online? Trevor or Rémi?
Oh, I'm happy to just throw, I mean, I'm conscious we've only got a couple of minutes. Alan, that's a big question. I think one of the things I'd emphasize is actually a point, well, sorry, obviously your answer as well, Alan, but a point that was made earlier, I think by Olivia, that you need to get people on board with what that end goal looks like, but then you need to show small success frequently at the start. And there's a degree of kind of big sale, but you can't wait 3 years to show any value. You've got to be showing value immediately and then building on success. And ideally, finding a partner who's comfortable with the occasional failure, because there will be.
Failure in an organization and even in a government-run organization is a very difficult thing to sell. But you're right, if you're not comfortable with failure, then you've not taken big enough leaps.
Maybe I can share my experience on that as well. According to the challenge the client want to solve, it can be easier or more difficult to for him to invest in transformative innovation. As Trevor said, it's very important to demonstrate early in the project if the client agree that he will have some success. And basically, when we were working with mining companies, if the challenge is very strong for them or can make them more efficient, they are keen to invest in innovation, but they want to be sure that they will have some results and trust in the results. And at the end, the outcome of the project is driven by their need and the integration of Earth observation services into their own workflow. So remote sensing Earth observation is designed to be an addition to their workflow and not the mining companies that are acquiring, as an example, the Earth observation capacity.
That's right, a tool rather than an end goal in itself. Well, unfortunately, we've now run out of time. Apologies to the room who had other questions. Perhaps submit those to us and we'll get them answered, maybe from Aude or Olivia or Rémi and of course Trevor. Would you please join me in thanking all of our fantastic panels for a fascinating conversation?